Here is the verse of today, Matthew chapter 5, verses 11 through 12. Blessed are you when others revile you and persecute you and utter all kinds of evil against you falsely on my account. Rejoice and be glad, for your reward is great in heaven. For so they persecuted the prophets who were before you. So we're encouraged this morning to know that when we take an authentic stand for our Lord Jesus Christ on his account, not on our own, so it's not something that we're looking for, no praise or glory for us, but honestly just for him, then we need to rejoice. We need to be reminded because God has a reward for us in heaven because of it. All right, let's go ahead and pray. Father, thank you for this day. Thank you for your kindness towards us. I thank you for my students. And I ask now that as we get into one of these key foundational lessons, you would help me again to explain the equations and the process of solving in a way that's understandable and retainable. And I pray that you would put in my student a heart to just practice and practice and practice and practice and just not to give up, but trusting in you. Thank you that you're approachable and that you care about things like this. And so I pray for success for my student this year. We give you praise and glory in Jesus' name. Amen. This lesson is about solving equations with variables on both sides. So let's just get right into it. Example 1. We're going to solve each equation. So we begin with the equation 7k equals 4k plus 15. Now, I'm going to introduce a teaching technique that's used to kind of help things along a little bit. Not everyone teaches it this way, and not all students need this technique, but some students find it helpful. And so the technique is to put a line straight down the middle through the equations, because what's going to become important for us to know is what is the left and what is the right. And sometimes for some students that line helps. So 7k is a term on the left. 4k plus 15 is a term on the right. And 7k and 4k are like terms. But there's a problem. They're separated on different sides. The only way to correctly collect them is to do the inverse of one of the terms to the other side. Actually, to both sides. So what we do is we choose to subtract 4k from both sides. Remember, an equation is like a scale. So what you do to one side, you have to do to the other side to maintain that balance. So we do that. 4k minus 4k cancels out, leaving me the number 0, which actually simply leaves me the number 15. 7k minus 4k, these now can be collected as like terms, and I get 3k. The operation between 3 and k is multiplication. So we do the inverse operation of division. We divide both sides by 3, and we get the solution k equals 5. Always take the solution and plug it back into the original, and you'll see that it's the correct solution. All right. Let's go ahead and look at the next one. So I'm going to put that little helper line down the middle. So we have the equation 5x minus 2 equals 3x plus 4. So notice that 5x and 3x are on different sides of that line. They're on different sides of the equals. So we choose the inverse. We subtract 3x from both sides. 3x minus 3x cancels to the number 0. We're left with the number 4. 5x minus 3x is 2. And now again, we choose the inverse of subtracting 2. 2 is a like term with 4. But to move it to the other side, we have to choose its inverse. So we add 2 to both sides of the equation. So minus 2 plus 2 cancels out to 0, leaving me with just 2x. 4 plus 2 is 6. The operation between the 2 and the x is multiplication. So I divide both sides by 2. 6 divided by 2, and I get 3. plug that back into the original equation. So replace x with 3. 5 times 3 is 15. 15 minus 2 is 13. 3 times 3 is 9. 9 plus 4 is 13. Check. That's a true equation. All right. Go ahead and try these on your own. Go ahead and pause the video now. Okay, let's look at the first equation. 4b plus 2 equals 3b. I subtracted 4b from both sides because the 4b and the 3b were on different sides. These canceled to 0, leaving me with the number 2 is equal to negative 1b. Now it's time to divide both sides by negative 1, leaving me with the solution of b equals negative 2. Now I plug it back in. 4 times negative 2 plus 2 equals 3 times negative 2. Well, 3 times negative 2 is negative 6. 4 times negative 2 is negative 8. Plus 2 gives me negative 6. This is a true equation, so the solution checks. Taking 0.5y plus 0.3y equals 0.7y minus 0.3. On this side of the equation, I have two terms which are like terms. There's no need to do the opposites or the inverses. So we're going to do a little CLT, combine like terms. So add them like you normally would. 0.5 and 0.3 gives me 0.8y. But now it's time to do inverses because I find that 0.8y and 0.7y are on different sides of the equals. So I subtract 0.7y from both sides. This gives me 0.1y is now equal to negative 0.3, which is what I had here. Divide now both sides by 0.1. This goes in negative 3 times. There's the solution, so let's check it. 0.5 times negative 3 plus 0.3 times negative 3 equals 0.7 times negative 3 minus 0.3. This gives me negative 1.5 minus 0.9 equals negative 2.1 minus 0.3. And so negative 2.4 is equal to negative 2.4. And the solution checks. All right. To solve more complicated equations, you may need to first simplify by using the distributive property or combining like terms. Solve each equation. Here we have 2 times the quantity of y plus 6 equals 3y. We have to use the distributive property. So 2 times y plus 2 times 6. Combine like terms or do the multiplication. 2 times y is 2y. 2 times 6 is 12. And now we find that 2y and 3y are on opposite sides of the equal sign. So we subtract 2y from both sides, giving me that y equals 12. I'll let you read in the book how the check works out. In this equation, I have 2k minus 5 is equal to 3 times the quantity of 1 minus 2k. So now we have to use the distributive property. So we distribute the 3. 3 times 1 minus 3 times 2k. I hate that bell. 3 times 1 is 3. 3 times 2k is 6k, but this is a minus, so negative 6k. Now I can see that this and this are on opposite sides, so I add 6k to both sides. Combining 2k and 6k gives 8k. Carry down the minus 5 equals 3. I notice that negative 5 and 3 are like terms, but to move them to the other side, I have to do the inverse of minus, which is adding 5. 3 plus 5 is 8. Division is required because this is 8 times k, so the inverse of multiplication is division. So I divide both sides by 8, and I get the solution k equals 1. 3 minus 5b plus 2b equals negative 2 minus 2 times the quantity of 1 minus b. All right, let's throw in the line here. Again, this is just a helper, a teaching tool. Well, I noticed that these two terms are on the same side of the equation, and since that's the case, they're like terms and we don't need inverses. We can just combine them like normal. Over here, however, I have to use the distributive property first. So I'm going to be distributing a -2. -2 times 1, -2 times -b. Well, -2 times 1 is -2, and -2 times -b is positive 2b. -2 minus 2 is -4. Finally, combining these two guys, because inverses aren't needed when you're on the same side, I get -3b. Okay, now it's time to start using inverses because everything that's a like term is on opposite sides of that equation. So I choose to add 3b to both sides. These cancel away to 0, leaving 3. These combine to give 5b, and I drop down the -4. Now it's time to do the inverse of -4, which is to add 4 to both sides, and I get 7. 7 is equal to 5b. 5 times b, and the inverse of multiplication is division. I divide both sides by 5, and I get 7/5, which as a decimal is 1.4, and that's equal to b. And this leads to a really important point. Your solutions do not have to be nice, perfect whole numbers or nice integers. You can get decimal answers and still be correct, but you only know if you're correct when you do the check. And so sometimes in algebra, we accidentally do our students a disfavor because we want them to learn the process so hard, we only give them solutions that are nice whole numbers or integers. And that gives a false impression to the student that if they somehow get a decimal answer, well, then clearly I've done something wrong, haven't I? But that's simply not the case. All right, go ahead and solve each equation and then check your answer. Go ahead and pause the video now. Here we go. First, we distribute the 1/2 into the quantity. So 1/2 times b is 1/2 b. 1/2 times 6 is 3. So I get 1/2 b plus 3 equals 3/2 b minus 1. Now I notice that the like terms are on opposite sides of the equals. So I do the inverse. I subtract 1/2 b from both sides. These cancel away to 0, and I drop down the 3. 3/2 minus 1/2 is 2/2, but that's 1. So I get 1b, or just b. Drop down the -1, and now I do the inverse of subtracting 1. I add 1 to both sides. I get b equals 4. Plugging 4 back in, 4 plus 6 is 10. Half of 10 is 5. 3/2 times 4 is 6, and 6 minus 1 is 5. 5 equals 5. There's the check. Second question, 3x plus 15 minus 9 equals 2 times the quantity of x plus 2. I notice that 15 minus 9 are like terms, so I perform a little CLT. Combine like terms. 15 minus 9 is 6. Now it's time to distribute this 2. 2 times x is 2x. 2 times 2 is 4. I notice that these terms are on opposite sides, so I choose to do the inverse of 2x, which is to subtract 2x. 3x minus 2x is x, or 1x. Carry down the 6. 6 and 4 are like terms, but they're on opposite sides. So I do the inverse of subtracting 6 from both sides. 4 minus 6 is -2, so the solution is x equals -2. Time for the check. 3 times -2 is -6. -2 plus 2 is 0, so I get 2 times 0, but 2 times 0 is 0. -6 plus 15 is 9. 9 minus 9 is 0. So 0 equals 0. There's the check. An identity is an equation that is always true, no matter what value is substituted for the variable. The solutions of an identity are all real numbers. Some equations are just always false no matter what. These particular equations have no solutions. Okay, so let's look at some examples of when we have infinitely many and when we have none. Let's take the equation x plus 4 minus 6x equals 6 minus 5x minus 2. All right, let's draw our helper line. Okay, so what can I combine on the same side? I notice the book isn't going to quite do this the same way, but let's just go ahead and proceed. Well, 6 minus 2, those are on the same side, so I don't need inverses. So 6 minus 2 is 4. And let's see here, x minus 6x turns out to be negative 5x, because this is a 1x, 1 minus 6, negative 5. Add 5x to both sides. That's the inverse of subtracting 5x. Well, the thing is that these zero out, they cancel. And that's exactly what happens here also. So what happens is the variable x is now completely, totally, utterly eliminated from the equation. And that leaves us with 4 equals 4, and that's always true. So what this means is it doesn't matter what x is equal to, the equation just is always true no matter what number you would have put into the equation. And so that's an example of infinitely many solutions. Let's now begin with the equation negative 8x plus 6 plus 9x equals negative 17 plus x. Let's go ahead and pop in our helper line there. All right, now let's combine like terms. I notice that negative 8x and 9x are on the same side of the line, so inverses are not needed. So negative 8x plus 9x is just 1x. I now subtract x from both sides, and I notice that the x's cancel away, giving 0 in both places, which means x has now been completely, totally, utterly eliminated from the equation. This gives me that 6 is equal to negative 17. And no matter what happens, this equation is just always true, always false. 6 will never equal negative 17. No matter what value of x you plug in, this will always be a false statement. And that's when you get a no solution problem. All right, go ahead and pause the video and try these on your own. Okay, here's the problem. 4y plus 7 minus y equals 10 plus 3y. First thing I do is I notice that 4y and minus y are on the same side, so inverses aren't needed. 4y minus y, 1y is 3y. Now I subtract 3y from both sides, and both of them cancel out to 0. I'm now left with the number 7 is equal to the number 10, and that's a contradiction. That is never, ever true. And since that is never, ever true, that means that no matter what value of y I could have chosen, there's just no solution to this equation. So this equation is a no solution equation. Okay, we're going to do this problem together. So I notice that on this side of the equation, there are two terms that are like terms, 2c and c, which is 1c. So I don't need inverses. I can just combine them. So 2c plus c would be 3c. Over here on the right side of the equation, I have two constants, which are like terms. So negative 14 plus 21 is the number 7. So now let's write out what I have. 3c plus 7, I'll try and keep the equal signs lined up, is equal to 7 plus 3c. Okay, now we're going to subtract 3c on both sides. And let's add a little visual bling here. So negative 3c here, we subtract that there, and we subtract it here. Well, the problem is, it's not really a problem, it's just a fact, is that these cancel away to 0 on both sides, and I'm left with 7 is now equal to 7. And that's always true. So no matter what the value of c is, I can always get something that's true. So this is a problem that has infinitely many solutions. Example 4, consumer application. The long-distance rates of two phone companies are shown in the table. How long is a call that costs the same amount no matter which company is used? What is the cost of the call? All right, phone company A, I notice, is 36 cents plus 3 cents per minute. This must have been a 1980s problem. Company B is just 6 cents per minute with no initial cost. So the question is this: how long is a call that costs the same amount no matter which company is used? So in other words, once I have the expression for company A and the expression for company B, the question is, when are they the same? When are they equal? So when is 36 cents plus 3 cents per minute times the number of minutes, which we'll call M, the same as, which is equals, 6 cents per minute times the number of minutes, which is M. So we get the equation, 36 plus 3M equals 6M. Subtract 3M from both sides. These cancel away, giving me 36 equals 3M. 3 times M, so the inverse operation is division. Divide both sides by 3, M equals 12. The charges will be the same for a 12-minute call using either phone service. To find the cost of this call, evaluate either expression. It actually doesn't matter which expression. Why? Because you had set them equal. You found the value of M that makes them the same. And that's why it doesn't matter which expression you use. So if we plug 12 into the first expression, we get 72. If we plug 12 into the second, we get 72. So the cost of a 12-minute call through either company is going to be 72 cents. All right, here's number 4. Go ahead and pause the video and give it a try. All right, this one I've just worked out, so you should get that Greg is 10 years old. Here's the think and discuss. Tell which of the following is an identity. Explain your answer. Here's the graphic organizer. An equation with variables on both sides can have one solution, many solutions, no solution. And here's the homework. God bless you, wherever you are today.
Sweet God, from whom all blessings flow. Praise Him, all creatures here below. Praise Him above the heavenly host. Praise